Alright, welcome. So today we're going to attempt section 3.4 one more time. So I understand we're never going to get out of 3.4, but there's so much to do in 3.4 that I thought maybe instead of rushing through it, we'd go ahead and just take our time. So today we're going to look at equations that involve natural bases and natural logs. Alright, and we're going to go ahead and just jump right into an example and hopefully get through with this lesson today. Alright, so example 1 you're going to solve. So I'm going to start off with 7e to the 2x. So I'm going to start off with natural bases. Minus 5 equals 58. Okay? Your job is to get x by itself, just like any old equation. So my first question would be, well, what do? You're trying to isolate this. Okay? Hoping you said, hey, you know what? I think I'll go ahead and move the 5 over to the other side. So now we're left with 7e to the 2x power is equal to 63. Alright, again, you're trying to get x isolated. So what else could I get rid of? Alright, how about dividing by 7? So we're getting there. Each step we're getting a little bit closer to isolating x. And now I get to the point where I need to get this out of the exponent. So my question is, go back to, I'm going to come over here and do like a side note. What if it were 1/2 x equals 8? And I asked you, what would you do? You'd say, oh, I'd multiply by 2. So do you realize that you're multiplying by the reciprocal, but you're also multiplying, another way to call it instead of a reciprocal is an inverse operation. So what's the inverse function to the natural log? The natural base would be, gave it away again, natural log. So if I take the natural log of this side, which remember from last night's video I'm allowed, I would also take the natural log of this side. Now what's the natural log of the natural base? Just the exponent. 2x equals the natural log of 9. Now again, you've got your two options. So my pure mathematicians are going to take option 1. They're going to say, you know what, I know if I punch that into my calculator, I'm going to get a decimal. Not happy about that. So I'm just going to write it as x is equal to the natural log of 9 over 2. Alright, and that's going to be your answer. You're going to understand that this represents a number, so we're good to go. Alright, for my guys who say, you know what, pure math is overrated, I'm going to go ahead and convert this puppy to a decimal. I understand by doing that, I'm getting a rounding error, but I'm okay with it. Alright, so take the natural log of 9. So grab your calculators. Again, you know mine is not wonderful being visible on the scene. But go ahead and hit natural log of 9, and you get 2 point, and again, I'm going to carry it out 3 decimal places, so 2.197. So 2.197, and now you'll just divide by 2, and you get 1.099. Alright, again, understand this has a bit of a rounding error. If you were to go over here and type it in, natural log 9, remember to close your parentheses, divided by 2. Alright, I get 1.09861. So again, I have a teeny bit of a rounding error, but for me, you know, that might be okay. I'm going to accept either answer, just so you know, on the test. Okay? Alright, second equation we're going to look at is a little bit different. I have e to the 2x minus 8e to the x plus 7 equals 0. And at first glance, you're like, ooh, not so sure about this, Miss Hoffman. So what I want to do is I'm going to kind of come over here to the side and say, well, what if we just ignored the e's and the x's for a minute? What if I had y squared minus 8y plus 7 equals 0? What if I had given you that problem? You'd say, oh, I know what to do. And it would be to factor it. And you would have y and y. Last term is positive, so it's either a plus plus or a minus minus. And I choose minus minus, 7 and 1. Okay? Let's take this and apply it over here. So I'm going to have e to the x and e to the x minus 1 minus 7 equals 0. Now I want to stop for just 1 second and make sure that you understand the differences between them. If you look at example 1, and I'm going to zoom out for just a minute. Example 1, only one term had the natural base. Here I've got multiple terms that have it. Plus here I have a trinomial. Here really I just had 2 terms, right? Because these combine to get 63. Alrighty. Now what do you do at this point over here after you had factored? You would go ahead and set both sides equal to 0. So let's go ahead and do that down here. So I have e to the x minus 1 equals 0. And e to the x minus 7 equals 0. So I have e to the x equals 1, or e to the x equals 7. Now again, how are you going to get rid of that natural base to pull this down? What's the inverse function of a natural base? A natural log. So I have x is equal to the natural log of 1, which is really, grab your calculator if you need to, that's one of our special guys. Natural log of 1 is 0. So even my purist, I don't want you to leave it as natural log of 1. I need it broken all the way down here. Now on this one I can take the natural log again of both sides. Now my purists are going to leave it as the natural log of 7. My option 2 people, you're just going to type in natural log of 7 and give me a decimal. So we'll go out to the thousandths place, so 1.946. Okay, so I have x is 0 and x is one of these answers, whichever one you like better. Alright, so that's how we're going to handle natural bases. So let's look at some natural logs. So in example 2, we're going to turn our attention to how to do a natural log problem. Okay, so example 2, solve. So I start off with 6 natural log 2x equals 30. Again, your job is to get x all by itself. So where do you think you'd begin? I hope you said divide by 6. You get the natural log of 2x is equal to 5. Now, right now, this x is attached to the natural log, so somehow I have to get rid of a natural log. And to get rid of a natural log, I'm going to take the natural base of each side. Now here's where it's going to get just a little, it's going to look a little wacky. I like to put my e's a little below because remember, an e is a base, this is its power. Now what happens to the natural base of the natural log? They are out of here and I get 2x equals e to the 5th power. Now again, you got choices. Okay? Some of us are going to want to take the pure route and leave it. Some of us are going to want to go ahead and plug in, find out what that is, and get a number. Okay, so my pure route is, well, what do I do now? I'm going to divide each side by 2, and my answer is going to be e to the 5th over 2. Or my people who say, you know what, I'm okay living with a rounding error because to me it makes a whole lot more sense to deal with numbers. And, you know, right now we're in advanced math, we're not in pre-calc, I'm okay if we do a little bit of that. Alright, so on your calculator, go ahead and type, let's see, we had e to the 5th, right? go ahead and type e to the 5th. So now to get your e, remember you have to hit the shift, so second natural log, and then type in a 5 and press enter. Okay, so you get that 2x is equal to 148.413. And now you're going to divide by 2, and you get that x is equal to 74.207. Okay, for those of you who did it this way, let's just double check and see how far my non-purists are. So you'd have e to the 5th divided by 2. And so you can tell they're off slightly, if you could see it. Okay, but again, not by too much. So you have to decide, you know, how important is accuracy. And if you understand this way, by far, this is the better mathematical way. But for some of us that are just learning with these logs, it's easier to put in a number. Okay? Alright, next. What if I have the natural log of the square root of x plus 4 is equal to 1? So this time, again, to get x by itself, the first thing I have to get rid of is what? I gotta get rid of the natural log. I understand I'm going to have to get rid of the radical as well, but right now I need to start by getting rid of him. So how do I get rid of a natural log? I'm going to take a natural base. Okay? Now, I'm going to take my two options. So, my purists. You're at this point going to say, well, the natural base of the natural log is gone, and I have the square root of x plus 4 is equal to e. If you want, you can put a first power. Now, how are you going to get rid of your radical? You're going to square it, which means you have to square this side. So your radical drops, you get x plus 4 is equal to, when you take e to the first power and square it, you get e squared. So your final answer will be e squared minus 4. Okay? My guys who say, you know what, that's nice, but I'd rather go ahead and turn this into a number because I can deal with that. So you have the square root of x plus 4 is equal to, you grab your calculator, and you say, oops, what e, if you want, you can put to the first power, and I get this, 2.718. Okay, and again, I apologize for the glare. I really need to get the it on my computer so you could see. Alright, now we go about solving your problem. How do you get rid of a square root? Oh, I square it. Now, I will give you guys a little hint. When you're showing me your work, you can type all that out, but if you come here and just square your answer, that way you don't get a rounding mistake, and now I can even say minus 4, and round at the very end, you'll get much closer to what the purists will get. Okay, so if you don't retype this in the calculator, you'll become much closer. So 7.389 minus 4 minus 4, so x is equal to 3.389. Alright, let's see how close we were. Type e to the second power. Whoops, helps if I... Okay. My calculator's being silly. Let me turn it on again. Alright, e to the second power minus 4. And I end up with 3.389, and look, I'm pretty doggone close this time. Alrighty? So, you decide, again, I'll accept either answer. Either it left as the mathematical true answer, or if you've rounded it. Okay? Alright, so I think the last thing I want to do is take this one step further and do the last set of equations. And I kind of saved these for the end. These I think you're going to enjoy, or at least enjoy more than the others. Now, what do you notice about this one that's different than the rest? So we've done ones with natural logs before, but have we ever done anything that all of them have a natural log? So the good news when all of them have a natural log is we're going to be able to do something slick. But the first thing I need you to do is this is expanded. I need you to condense it. So when I see minus, I know that that's really division. Now here's what's fancy. Since they are the same thing, they're both natural logs, we can just drop them, just like we did the natural bases, or even a regular base if they're the same. So since they're the same, they're gone, and I have x minus 3 is equal to 7x minus 23 over x plus 1. Alright, to solve this one, we're going to multiply each side by this x plus 1. So these go away, and I'm left with 7x minus 23. What do you need to do over here when you have two binomials? We're going to FOIL them. So x times x is x squared. Outer, negative 3x. Inner, 1x. Last, negative 3. So I'm going to clean it up a little bit. I have x squared minus 2x minus 3 equals 7x minus 23. Now what? Since it's a quadratic, we got to bring everything over, zero it out, and hope we can factor. Alright, so I have x squared, bring the 7x over, I get minus 9x plus 20. So I say, is there anything that would multiply to give me 20, add to give me 9? Yep, how about 5 and 4? So my answer is x equals 5 or x equals 4. Okay, last thing to double check. Do both of these work? Because remember, the natural log function has a requirement that it can't go negative. So what I need you to do is I need you to come up and plug in each of these numbers into all three. Okay, so check. And I don't need to see your check written out, but I need you to do it in your brain. Alright, so I take the natural log of 5 minus 3, the natural log of 7 times 5 minus 23, and the natural log of 5 plus 1. And all I want to make sure is, are these positive? Are they 0 or above? This would be the natural log of 2, yep. This is the natural log of, let's see, 35 minus 23 is 12, yep, that's good. And this is the natural log of 6, so it's good. So that means 5 works. Now we need to check 4. So go back in and check 4 in all of them and see if it indeed works. Okay, so this time I'm going to try to do it verbally instead of writing it. Plug 4 in. What's 4 minus 3? 1. That's good. 7 times 4 minus 23 is 5. That's good. 0 or higher. Plug it in here. 4 plus 1 is 5. Natural log of 5 is good to go. So both these answers work. Alright, we'll do one more of those tomorrow where the roots don't necessarily work, and that's where we'll pick up from there. Okay? You guys have a great evening. Don't forget to try a couple of your practice problems, and I will see you in the morning.